If you're scanning a large Wi-Fi network, it can immediately become confusing as to which devices are connected with which networks. Fortunately, there's a tool called Airgraph-ng, which we can use to visualize these relationships. We'll show you how this works on this episode of Cyber Weapons Lab. One of the first tools that most hackers learn when they're interested in hacking Wi-Fi is the Airgraph-ng suite of tools. Now this includes a whole lot of different subtools, and some of which we've actually covered in previous tutorials. One example is Airodump-ng, which takes a compatible wireless network adapter and lets us listen in on any nearby networks along with devices that are connected. We can then drill down on anything that we want to target by selecting a filter that maybe picks a specific channel or even a specific network to filter out everything else so we're only listening in on one target. While this is really useful, it can also get really overwhelming in situations where there's a whole lot of wireless traffic, like maybe a coffee shop or an office or something like that. Fortunately, there's another tool inside Airgraph-ng that's really useful for this sort of thing, and it's called Airgraph-ng. Now, predictably, this generates graphs, and what those graphs show is information about the relationship between client devices and the wireless networks that they're connected to. Now, in order to use it, it's relatively simple because it's included in Kali Linux. But if you have Debian or Arch, it's also pretty easy to install. Now, the one thing you will need is a compatible wireless network adapter. And if you're confused about this, we actually have a number of tutorials on Null Byte that'll help you through the selection process. Once you have a compatible Kali Linux wireless network adapter, then we can begin. Now, in order to show off a real network, we recorded this previously in a coffee shop so you could see what a real network looks like under this sort of graph. To start, we can type man Airgraph-ng in order to take a look at the man page of this particular tool. And in general, this is a good way to check out any tool that you're going to run for the first time. Here you can see there's a couple inputs, outputs, and also a specification of which type of graph we want. You can see there's client to AP and common probe graph, which I'll explain a little bit more later on. Let's go ahead and run man Airodump-ng to see the other tool we're going to be using. And the most important flag is this TACW, which will allow us to write this file to a CSV file that will later be used in Airgraph-ng. We'll type Q to quit, and then we'll go ahead and select the wireless network adapter we're going to be using for this monitoring, which is going to need to be put into monitor mode first before it'll work. So we can type ifconfig in order to locate any wireless network adapters that are attached to this machine, and you can see that mine says mon after it, which means that it's already been put into wireless monitor mode. If yours isn't, then you can go ahead and type Airmon-ng, start, and then the name of your wireless network adapter. But because mine's already in wireless monitor mode, we don't need to worry about doing that, so I won't run that here. Now to start, we'll run Airodump-ng with a minimum of flags where we just put in the name of our wireless network adapter, put into monitor mode, and then we can go to our desktop and drop in a file here in order to get the file path so that it's obvious for us to find this file a little bit later on. So once we run this, we'll be able to see all of the wireless networks in the area, as well as all of the clients, aka cell phones or laptops that are in range as well. Now this can be really confusing to a beginner who doesn't understand it, so as you can see, this kind of just keeps scrolling and scrolling and scrolling and doesn't really give us an immediate understanding of what's going on here. Now to fix this, we can let it run for a little bit, and after it kind of scrolls around for a bit and gets a list of all of the networks and all the clients, you can also note that on the left side, it's going to scroll through every single possible channel all the way up to number 13, and all the way up to 14, although that's not very useful in the United States. So we get the maximum kind of wide picture of what's going on in this general area, not just what's happening on any particular channel. When we're done, we can press Control-C, and that'll allow us to start to take this CSV file we generated and use it into a more readable format and make it so it's easier to understand. Now we can type ls, and here we go. We've actually managed to save this information to a CSV file. So we can take the next step of actually putting this into Airograph-ng, which we'll start out with Airograph-ng. we'll type in the input flag, which is tac I, and then we can just drag and drop the file we created from the desktop where we saved it. But now we'll need to specify where we want the output file, which will be a PNG. So I'll take the same file, so we can copy the file path, and then change the name of the file just to packet-test-01. So then we'll need to specify the type of graph. And in this case, I want to take a look at devices that are connected to networks. So we'll type CAPR and then return in order to generate a graph of the relationship between devices and networks. So when we open this, we can see a graph that doesn't represent all the wireless traffic, but does show all of the current networks that have clients connected, as well as information about the clients that are connected. So here we can see there's 4 in this Bourgeois Pig network operating on channel 6, and we can even learn about the manufacturers of these devices as we scroll through and take a look at these arrows pointing to the various clients that are connected and exchanging data with these networks. Now, as we scroll around, we can see that there's subtle differences in the way and channels that these networks are operating on. And that can give us more information about how to filter this down, so maybe we're not looking at such a broad scope and instead we're looking at a more narrow picture. Now, I mentioned that we're not actually showing devices that are disconnected, so let's take a look at that with a different type of graph. We can type Airgraph-ng tac help, and this will show us that the second type of graph is called a common probe graph, which will focus on devices that are calling out for networks that they are not currently connected to. Now, we'll just run the same command again, but change the file name so that we can actually see it as different, and then specify it as a CPG graph. And after it renders, then we should be able to open it in the same window here and see that it is instead a graph of networks that these devices have connected to in the past. Here we can see this particular device has actually connected to Cafe Vita, the Intercontinental Hotel rooms, and a couple other networks. So we've learned a fair amount about this person's device and places that they've been to before simply by listening in on the wireless traffic here for a little bit of time. We can also see that there's other devices that have similar networks in common that they are allowed to join or attempting to join. And we can see other indications of networks that are not present here, but would cause any of these devices to instantly connect, allowing an attacker to basically hijack the data connection of these devices by putting up a fake network that has the same name. Now, while this is interesting, let's say we want to drill down a little more carefully and only see information on channel 6. Now, the way to do this is to just rerun our Airodump-ng command, and we'll go ahead and specify channel 6 so that we're not getting any of the other information that would be found by hopping around to other channels during the scan. And of course, we'll actually need to type tac-c, not just tac-6, because the script needs to know that we want the channel. So here you can see it worked because the channel is set to 6 and it is not just kind of jumping through everything. And this is how we'll be able to get more information and maybe even detect some hosts that we missed by jumping through a bunch of channels the first time. This will generally be the step after the hacker identifies the network that they want to focus in on. And this will eliminate all the other networks that were detected on different channels, but increase the likelihood of getting a more specific picture of what a particular network operating on one channel looks like. So we can press Ctrl-C to exit, and then we'll need to specify the new file that we generated here in our Airgraph-ng command. So we will specify the name as channel 6, and then we'll need to go back to our desktop and grab the file we just generated right here, channel 6 only -1 CSV. And as soon as we run this, then we should have a new file, a PNG called channel 6, that shows the relationship of, there we go, that shows the relationship only of channel 6, aka any devices that are operating on channel 6 and only channel 6. So initially we only found 4 clients, but after changing to only channel 6, we've managed to locate 5, meaning that by staying on this channel, we increased the likelihood of maybe finding a device that was transmitting only once in a while, or that we were just missing continually by being on the wrong channel when it was transmitting. This can allow an attacker to really filter out the noise and get the bare bones picture of what they need to attack on a network where maybe they go into it with zero knowledge. So by rendering the information in a more graphical layout, we can really start to understand what these networks are doing behind the scenes. While many of the tools included by default in Kali Linux come with a warning that you can only use them against networks where you have permission, this one is a little bit different. Because we're just passively listening in on wireless traffic that's in transit, we're not actually interfering with any networks or kind of interacting with any devices on the network. This is really good because it means we can run it basically anywhere. And for an attacker, it means we can sit down in proximity to a target and learn everything we need to execute an attack from start to finish just from listening in. Now, we can also get the information we need to run more powerful scripts like bsetng from an initial scan. So this is a really useful tool for any attacker or anyone who wants to know what's going on in the nearby wireless area. That's all we have for this episode of Cyber Weapons Lab. Make sure to like, comment, and subscribe. And if you have any thoughts or ideas for a future episode, send me a message on Twitter because I would love to hear it. We'll see you next time.